Hello then. I am Amy. If I don't actually believe that we've fully exchanged names here either. So I'm Amy. My handle on everything, including GitHub and Twitter, is Red Rocks Projects. If you want to talk to me about anything, you can get me on the normal social channels, as well as my DMs are open always about events and stuff, because I do the community management side of developer relations at Pusher. So what does that actually mean? Well, it means a lot of things, but I'm actually going to tell you a little bit about what is Pusher and why we're talking about gaming at the moment in a big way. So I'm going to talk to you about real-time events in games, the user experience danger zone, and I'm not actually going to talk about the good. I'm just going to show you some bad and really ugly stuff, because I figured that's more fun. And then I'm going to talk to you about our product, which is Pusher Channels, and how we can help you do some of this stuff. We've got a Unity SDK that we've been building out it's just launched in, I want to say September, and we've used it a couple of hackathons. So we're gathering feedback about that right now and trying to really help people who do games development get places with this. So yeah, real-time events in games. So the first thing is to talk about event-driven architecture. It's been quite a popular thing in gaming, but also in software development for a few years now. In gaming, it's trying to create this infinite replayability idea that stuff is constantly changing, that you can make a playthrough, not just a game loop. But in software, we're talking more about responsiveness and connectivity and making sure everybody has everything on the same page. And really, that's why we kind of got involved, because connected experiences are a big thing of what we do at Pusher, but they're a huge part of gaming too, even through AAA games right now having lots of online spaces, and going for pushing everything online to having updates for downloadable content as well. So it's a really big space right now, and it's something that we can do a lot in. So we thought we would give it a go along with many of the other use cases that we have. There are so many challenges with event-driven architecture though, and that is managing multiple devices, maintaining the user experience without breaking game narrative, having multiple connections and not losing them, or multiple threads and being able to do that. We know that's a particular problem in Unity and some of the limitations that we've been trying to work around as well. And also the UX of this is kind of really important in the game, but there's one thing about human perception and technology, which is that with real time, you have to have you can't have so much latency. You can have enough. I think it's anything under 100 milliseconds is perceived as in real time, but anything, the 1 second or less rule is kind of anything under a second. People can more or less go, yeah, that's responsive. But if you do anything if you get into 10-second territory, people will leave. They just will abandon ship straight away. So my background is actually in user research. I was a PhD candidate at Nottingham University doing mixed reality. And one of the things that I studied was actually accessibility in digital musical instruments, and the real-time responsiveness of music is super important, even more important than what you have in gaming. I would feel you can cope with a bit of screen lag, but you can't cope if you're making drum hits and the drum sounds 10 seconds later. It's really, really bad. So yeah, there's also a lot of things about real-time events is that you can do so much now about game state and communication. So just this is where they excel. So updating the state of the game, having multiple people controlling the same game, or scoreboards, or even real-time chat within your game. Those are the kind of areas that you can use us for. So let's talk about why real-time events are great, but sometimes designing a game very, very well doesn't work very, very well with real-time events. And that's because sometimes you can deal with things like cognitive overload. So if you create an event that triggers something on a repetitive basis and too much of that happens, especially if it's audio, that's a big no-no. And some games are perversive games are designed to do the antonym of this. They don't want it to be an enjoyable user experience, and there's purpose in doing that. But these are definite things to try and avoid if you're going for a game that you want a user to not be frustrated by. So if the game design isn't to frustrate your user, generally try to not overload them. In the same way, try to avoid confusion. So using plain English, being aware of colloquialisms unless it's part of your theme that you want to have stuff like that in there, but they shouldn't ever extend to the control interface of something. Purely because you want your user to at least be able to go, oh, I understand how this works, even if I don't really understand what the narrative is happening right now. And then over complex UI, so if there's too much happening on the screen, some games rely on this a lot. Like it's quite like Marmite for me. I like playing Smash Brothers, but I hate playing like a tournament because I just can't, I don't even know where I am on the screen. I can't do it, it's too much. I have ADD, I'm like, it's overload for me. So there are games that play on this, but if you go too far into this, you will definitely lose people. And latency, which is the big thing that we're working on with real time. So this can be really bad. If you do anything beyond 10 seconds, you'll cause frustration for sure. So let's, I've looked at this article called the UX Planet, 5 Examples of Terrible Game UX. I don't know if some of you may have seen this, but I thought I would show you some examples. Starting with Mega Man, which was the Maverick Hunter X. It's great. And I'll see if you can find out what the bad UX of this is. Does anybody know about this bad UX trait of this game? Can you guess now? So every time they use a special attack in this game, your player announces what the special attack is. So if you're button mashing or fighting an enemy and doing multiple of this, all you hear is homing torpedo repeatedly, and it's just complete sensory overload. So like, there's also this sense of like, even though Mega Man was never meant to be a realistic game, you've completely broken what it would be like to be in a shooter game, because nobody's going to announce, I'm firing a shotgun every time they fire a shotgun. Yeah, are you getting annoyed yet? Can you imagine playing an entire level of this? So this is another one, and you can probably tell by the contrast even right now that this is bad anyway. But this is the ARM-A series in the first game, which was called Operation Flashpoint. And this menu was the only way to do anything. So you had one button where you could fire your rifle, and then you had to use this menu for everything else. And it used the mouse wheel down click button to do that. So not only did you have like a really bad button interaction, but you had this menu that appeared, and you had to scroll through and select what you wanted every time you went near anything. And it would be all of the actions to do with the item you were stood near, and all of the actions that were possible in the game as well. So it's just like, you make somebody really frustrated because they have to navigate through that anytime. Can you imagine if you were, I don't know, in a time-sensitive situation within the game and you had to do this about 50 times? What's more about this game is that they relied on perfect positioning, so they didn't do zoning, they did literal, when the character is stood in this footprint, they can access this target zone. And that meant that if you moved your character off slightly, you couldn't then press the interact button at all. So like, you couldn't then interact with objects within the game. So I don't know how anybody managed to play this to its completion, other than because it's, you know, not the newest of games. Maybe it was just like one of it was bad at the time, but even games that came out in the like way earlier than this, like 10 years pre this, had better interaction design. So it's just one of those things to watch out for. And then here's another great one. Oh God, the contrast is really bad on this screen. But this is Half-Life 2. Anybody played Half-Life 2? Okay. Characters only explain things once. If you don't listen to the line, or you don't catch the text, and you bump into them again, or you go to interact with them again, all they give you is irrelevant banter. They don't give you the game instruction again. They don't repeat it. So if you play to a certain point and there was a really crucial piece of information that your game was going to give your character, that's it. You have to go back to the last save point and play it all again because you are not going to catch that line again. Nobody's going to deliver it to you. And this is the breaking the realism point. Like, nobody in real life would not be able to say, could you repeat that? And I know some games do this to like a level of annoyance. I get annoyed in Breath of the Wild because every time you speak to somebody, they repeat everything, and I'm having to like mash the skip button to be like, yes, all right, I know what you want. Like, I know who you are, we've been through this. But there is that element of, if you don't have that repetitive action, then like, what is your character meant to do if they didn't catch it? Really quite bad. So I know that I haven't really covered who we are, but at Pusher, we do lots of things related to real-time interaction and connectivity. And we started out with, we now have 3 products in the company, but we started out with one called Channels. And Channels is allowing you to do publishing subscription stuff on WebSockets. So we made WebSocket infrastructure really scalable, really like simple to call via an API rather than having to build your own WebSocket server. Now, for us, that's cool. You can see all of the stuff that we do with Channels at this site, and there is many use cases, but that does mean that it's like really broad. There's literally so much that you can do with Channels, because anything you might want to do, from an interactive whiteboard across web browsers to game controls to building a chat infrastructure to so many other things. And some of the time we have like tons of companies that use us, and most of the time we don't really even know what they're doing because they set it up and it just works for them. So we never really touch on, oh, what are you actually using us for? Because it's just so freeform.
Interactive showers.
Oh yeah, is that one of them? Oh, we've got Nanify as well, so like a platform for babysitting and looking after your child. And then we have like stuff in education. We have Microbit using us for their new classroom project. We have Netflix using us for something or other. GitHub users as part of, I think, desktop. Yeah, so we have like a ton of people using Pusher to do this real-time interaction, because doing WebSocket stuff at not just in the interim, but at scale gets really complex. And doing that at scale and trying to manage all your connections and also dealing with your server side stuff is a bit of a nightmare for most people. So they just pass it over to us, and we deal with millions of how many millions of HTTP requests per second? Like that's what we process, and it's what we work towards, and work towards reliability on that. So we actually have, see if I can do this. What take is? Yeah, we actually have some use cases on our website about AR, VR, and gaming. So we talk a lot about like what you can do with that. So having multi-device AR experience, having multiplayer game sync. There's all of these different things to kind of allow you to have extra things within your game without having to go through all that the complexity of building those features out on a server yourself. So there's real-time communications, presence channels, being able to do cross-device messaging, anything that you can trigger via an event and a data stream, we can handle, we can pass it over to you. And you can do that in many different ways. And Damiano is going to go through like all of the different models of the publishing subscription part of Channels. But yeah, let's see, no, wrong way. Did it just go in the top? Hang on. It's done this useful thing of opening in a new tab. Oh, well done, Amy. Okay, so the kind of things that we have seen people using this for in games is synchronization, tracking scores. We actually support quite a lot of global mobile gaming platforms that do like scoreboards and live tracking for that. Being able to do presence within a game quite easily and knowing who's joined a session. Being able to update locations, which is one of the things Damiano is going to demo. And being able to do multiplayer and multi-device in like a couple of API calls as opposed to having to build that out individually. Chat between players is another use case that we see, but there's loads more. Like it's pretty extensible. You can put it on a lot of things. So we try not to limit people's imaginations of what's possible with it. Because what we're really about is just connecting multiple people in experiences at the same time. So we care about connected experiences at Pusher, and that's something that we're working on. And our two other products that we have, one is called Beams, which is for notifications, and then one is called Chat Kit, which helps you build it's literally a chat kit to build that kind of function. If you already have an app running, stick Chat Kit on it to add chat. It's kind of what we have. But I'm going to hand you over now to Damiano, who's going to demo something that he's built in Unity with our new .NET SDK.
Right. I'm Damiano, and just to follow on what Amy presented earlier, I'm gonna try and explain a bit more like how it works under the hood, and maybe provide some demo examples that you can use in your games to get easily integrated with it. So today we're going to talk about like how to have real-time networking in your games and how you can build that with our product. So as Amy said, basically our product is public subscriber model on top of WebSockets, which is fancy words, but it just means that there is a publisher which publishes data. There are subscribers which are subscribing to this data, and so when a publisher publishes something, immediately the subscribers which are interested in the data that has been sent receive it over this protocol that is called WebSocket, which is an abstraction of HTTP, and it works by providing a bidirectional layer on top of the internet. Because with the HTTP model, you have a server and you have a client, and the client can receive information from the server only if it connects to the server, it asks for new updates, and the server provides them. But if the server has something to communicate to the clients, it's impossible in the HTTP model, because there needs to be a request coming from the client, and then the server can update it. It doesn't work the other way around. Instead, with WebSocket, what you do is you create a persistent two-way tunnel between clients and servers, where both clients and server can produce and consume information and send them on this channel. And this is what WebSockets basically are. WebSockets are open source implementation of a protocol, and you can create your own. They are provided by your browser, so every browser provides this interface to use them. But they are not easy to handle. They have some gotchas, and it's not easy to set up servers with millions of WebSocket connections, because those are persistent connections are quite heavy. So what we are seeing is customers are coming to us and saying, okay, I have 10 million devices that I want to keep connected, and I want to be able to push information to those devices as soon as the server has something to communicate, instead of them keeping asking the server about news, for example. And this is what WebSocket do. So we wrap around this WebSocket model, and we provide public subscription on top of it. You can do fancy stuff with this mechanism. So sometimes we see people being confused about like how they can use us, because the product is very flexible and they don't really get like what are the benefits of using it in a way, or what are the benefits of using it in another way, especially in games, because it's quite a nuanced approach. So we have several patterns. I'll show 3 of them, which are the most used and maybe the most interesting for games. So this is the one publisher and subscriber model. You have one publisher which, through an HTTP post here, publishes against our infrastructure. And then we have N subscribers, which are consumers of the information that the producer is providing. and they are being kept connected through these WebSocket tunnels consistently. So every time the publisher has something to communicate to the subscriber, it publishes an HTTP post against our server, and then we forward these to this persistent connection that we kept, which will then reach the subscribers. For example, let's say that you are building something like Twitch, where you want to stream something that is produced in a single source. So let's say this camera is connected to my publisher, and it publishes through HTTP against our pusher infrastructure, and whoever is connected to that pusher infrastructure as a subscriber will receive a stream of this event. So effectively we are multiplying this flux of data n times to all the subscribers in real time. Another use case for this could be you have a central server, which is the publisher, and for example, the server starts a game every 10 minutes. So the publisher says, okay, let's start now, and it will forward a start message to all the subscribers, which will then be able to interact with the game and coordinate them during the gameplay. So this is one simple model that we do. Another model, the picture is a bit ugly, but gets the job done. Another model is n publisher and n subscribers. So you have, for example, various sources of an information, and you have just one single subscriber that listens to this information. An example of this could be the game that James and his group are doing, which is this game where they have n players that connect to a website, and they can press sequence of keys. And these keys are what they produce, so they are publishers. And they could be n publishers, so there could be 3 players that publish key presses in here. So we can see that this key press flow follows along and pass through this central server that is pusher. And then what pusher does is it proxies these key press events in one single channel that reaches the subscriber, which is, in this case, the game itself that is receiving key presses from all the players that are playing. So this example is, as you may imagine, an example which can map a situation where you have a console. So the subscriber is the console, and the publisher are the controllers of the game that is going on. Right. So the game is going on in the console, which is the listener of the events that are happening, and the publishers are the game controllers that are publishing events and actions to the same receiver. And the third model, which is probably the most useful one in games, is the pub-sub, sub-pub presence model, where you have the same game running on multiple devices. For example, you can download this game that does tic-tac-toe on multiple like rooms. So you have a room with 10 users, for example, and they all play on the same tic-tac-toe board. I know it's weird, but it's an example, right? So they have this tic-tac-toe board where they play 10 people at the same time. So the game on each of the 10 devices is running, and it's communicating to all the other 10 devices through the pusher infrastructure with this pub-sub-sub-pub model. So what it basically does is someone plays on a specific cell of the game, so this information flows from the player to all the other players and populates the board of each other player with the move that player one made, and vice versa. And this synchronizes these kind of things. But you can do even fancier stuff, like you have, for example, a room again, and you have a Call of Duty map where you have enemies and friends, and you are doing a capture the flag thing or something like that. And you want your enemies and your mates that are on your team to see where you're going with your player, which action you're doing, and if you have been hit or whatever. And they want to be able to interact with you. And so these events are proxied from your device to the pusher infrastructure, which then fan them out to all the other players in that single room, which we call channel in our jargon. So this again is useful for example, real-time multiplayer, but you can do game state synchronization, synchronize position, scores, and synchronize game starts and stops and these kind of things. It's very easy. Yep, that was the theory part, and we can check out an example of this. So I created this repo called Pusher WebSocket Unity. It's under our GitHub organization. So this, I want to be clear here, Pusher channels is usable in a lot of devices, right? So we have our website, and you can go on channels, and you can check the docs, and you will see that you can basically select whichever language you are most familiar with. So we have JavaScript, Swift, and Objective-C for iPhones and Apple devices. We have Java for Android and for Java servers. We have Laravel, which is PHP if you want to build web pages. And these are the clients. So these are the subscribers that we saw in our model earlier. But we also have things like producers, which are in here. And the producers instead are running off of like a producer server, which is what you use to trigger your data against the infrastructure. You can build it in Rails, in PHP again, in Node.js, in Windows, Python, Java, whatever you like, even terminal stuff. So it's pretty like extensive as an interface. So you can publish and subscribe with a lot of languages, a lot of devices in a lot of frameworks. So that could be on PS4, on like Android apps, on iOS apps. It could be on VR headsets that support these models. But for the purpose of this demo, we will focus on Unity, which is a pretty solid choice in terms of game development. And what we are going to do is we're going to create a simple example, which is what I mentioned before in the example I was doing about the way with which we can control a game through an external controller that publishes actions against the infrastructure, and then the game receives the action and acts on it. So we have here like how the game looks like. We have this little character here, and we want to be able to, this is in Unity, we want to be able to join a room, a channel with this game, and then whoever connects to this room and channel and produces movements under the form of like key presses and arrows and stuff. We want with those like data streams of produced key presses to move this character, which is listening on this. So what we essentially are going to do is we're going to have a producer here with like a fake game controller. We are going to bundle these key presses on this controller and send them through an HTTP API onto pusher channels and publish them into a channel, which is like, again, sort of a room. And then in the same room, we are subscribing with the game, and the game will be set in a way that it will listen for these key presses and act on them. So this is a small guide on how to do it. You can do it yourself later on, or I'm not probably going through all of this. I'm just showing you bits and pieces, but you can reproduce it fully with this one. So you can clone the repository, this one, which will contain two folders. One is the game controller, and one is the game itself. And then you need to create an account on push.com. And with that, you create a channels app, which will let you create a room where you can publish your things. We can do that here, for example. See if we can do that. Yeah, I have a problem with my browser. Probably need to pull this up. Sorry for the mess. Okay, so push.com, we are going to go straight to, let's go with push.com, and then we want to go into the dashboard. Can do sign in. Yeah, I'm already signed in. This is our dashboard. We use channels. We want to create an app, which I've already created, but it's pretty easy to do. You just click create a new app. I'll show you how it is. You choose a name, you choose a cluster. This is important when you want to have low latencies. So if you want to have a low latency and you know that your players, the players that are playing your game are mostly in Europe, you can select the Europe cluster, so the round trip time between the pusher server and the users using it is shorter. Then you choose a name for your app, and then you can choose whatever front-end tech you want. So the ones that I showed you earlier. For example, we can choose Unity, and then you can choose your backend, which is what you use to produce. And for example, we are going to do it in Node.js. Once you create your app, you have something like this, I think, where you have an overview of like how many devices have connected to your game overall in the day, and how many messages they have sent. And to get started, you can copy the code snippets or just follow what we have in the guide here. And what you're going to end up with is you are going to end up with a directory where you have, can you see the font? Where you have the game controller and the game itself. So the game itself, it's a Unity game, and we can open it through Unity. So we open Unity, and I already have the game here, but it's just in that path. So here's the game. We have our player here, and the player is basically, let's inspector. See the inspector. Okay, so the player is basically a prefab, for those of you who are familiar with Unity prefabs, and it has two scripts attached to it. One is the pusher manager and one is the pusher mover. So the manager is what manages the connection, and then the mover is what is responsible for moving the player. So it's really simple. Basically, find the code for the connection manager for Unity. It's already in the repo. You can clone it, and then you set up your app key and app cluster, which is what is coming from our, sorry, where is it? Here, from our app keys section. So you copy your app key, your secret, and your cluster, and you put them into here, so you can connect directly to your app. And then what you do is you subscribe to a channel, which you can call whatever you want. I called it my channel. And when you connect, when like the connection is ready, this callback function is executed, which is called onPusherConnect. And what it does, it binds to an event. So events are prefixes that you have on the messages you are publishing, and you can, every message you send, you can call it a specific way, and then you can bind to all events that are named that way. So then you are connected to a channel, you publish something called run left. On the other side, you are subscribed on this channel and you are listening on events called run left. And then what it actually happens is you're pressing your key on your controller. An event is generated on your controller which sends on this my channel room an event called run left, and all the subscribers that are subscribed to this channel and that are listening to this event run left can act on it and do something. For example, we are acting on the receiver of the event run left, and we are changing our state to state run left, which will eventually trigger the movement of our player and make it move on the game. So this is the client part in Unity. So that is all we need to know about it. And it's pretty straightforward, I think. And on the other side, we have this producer, which is under game controller. And this producer is just, for those of you who are familiar with Node.js, is just a Node.js app, it's very short. And we specify our app ID, our key, our secret, our cluster, as we did before in the Unity bit. So then we can close the loop. And then we define that we are listening on key presses, and each key press is triggering an event, so it's producing an event on this channel, which is called my channel, and the event will be run left, run right, attack, idle. So essentially what we are doing is, if we start the server is available on localhost. We have our nice controller. We have our game. So the controller is now ready. Whenever I click things on it, it will publish to our pusher channel. And now I'm starting the game here. And what the game does is it starts and it says that it has been connected to pusher, it has been subscribed to my channel, and now it's ready to listen for events that we are publishing. So what we actually are doing here, we are now triggering an event, which is run right. The event is produced on the controller. The controller publishes the event against pusher. Pusher forwards the event to all the subscribed devices, which can be several, one of which is this device up here, which is running the game, and the game is acting on the event that we're publishing. And this is the overall flow. So we can run right, run left. We can attack. And we can do pretty much whatever we like on it.